Okay, in this tutorial for deflection of beams, we're going to find out the deflection for a simply supported beam, which is 12 meter span. It's got a pin joint on one end, a roller joint on the other. It's got a load P, which is going to be 24 kilonewtons, and that's applied 8 meters along the 12 meter span there. So we're going to use the integration method to find out the deflection. So first thing we need to do is work out the reactions and draw shear force and bending moment diagrams. It's pretty easy to see that the reaction, if we take moments, let's call that A, let's call that B. If we take moments about A, and this therefore becomes reaction A, that becomes reaction B. If we take moments about A, is going to be 24 times 8 minus RB times 12. We calculate that out. And we find that RB equals 16 kilonewtons. We'll take the moments about B, about this point here, and we'll go that 24 times 4 minus RA times 12 is going to equal 0. And we find that RA equals 8 kilonewtons. And 16 plus 8 adds up to 24, so we know it's correct. Okay, so far so good. Now we can draw the shear force diagram. The shear force diagram is going to look like this. We start off with a shear force of 8. We go along to where the load is applied. We put a load of 24 in. We go along to the last support, and if we put the values on that, that is 8 kilonewtons. That's still 8 there. That's minus 16, and that is 16. Okay, there's the shear force there. Now let's draw the bending moment diagram. Now, bending moment diagrams, as you know in this course, is a strong American influence, which says that we will draw the bending moment diagram positive above the line. There's also a strong Australian influence in this course, which says that you draw the bending moment diagram on the tension side. And by drawing it on the tension side, I mean that the bending moment diagram resembles the deflected shape of the beam. As long as you keep careful track of your signs through this, it doesn't matter which way you do it, as long as you're clear which way you're doing it. All right, so we'll do it the American way, and our bending moment diagram is going to look like this. And I should do the calculations to support that. If I cut it there, I can find out the moments. Let's call that point C. If I find the moments of C, then the moments of C, cut it this way. Have a look at that. It's going to be the reaction times 8, which is 8 times 8. So MC equals 8 times 8, which is 64 kilonewton meters. All right, 64 kilonewton meters. Now, I've drawn on the compression side, not on the tension side. So most Australian students look at this and go, you've drawn it backwards. Most American students look at this and go, yep, that's correct. All right. Now let's do an equation. Find the equation for the bending moment. Well, from there, in terms of x starts at 0 there and goes that way. So for x is 0 to 8, our bending moment is going to equal 8x. It's a straight line. When x equals 0, it's 0. When x equals 8, it's 64. And for x is 8 to 12, our m is going to equal 64, and it's going to decrease. So 64 minus 16x. We'll check that. When x is 8, it'll be 64 minus... Oh, that's wrong. Hang on. Might have to pause this. Okay, where were we? Sorry, I got that wrong. From x is 8 to 12, m is actually 192 minus 16x. And you can do that if you imagine projecting that line back all the way to here. That would be 192. But you put in x is 8, and you get 192 minus 16 times 8 is 64, and x is 12. 192 minus 16 times 12 is 0. So that is our equation for that side of the beam, and that is our equation for the second half of the beam. All right. Now we need to then integrate those two equations. So we're going to put them up there, and we'll divide our page in half and we'll integrate them. So over here we'll go, so the equation we know is that deflection is the double integral d squared y by dx squared of 1 over EI m in x, right? That's our basic equation for deflection. What we're getting at here, and I'll explain that in a minute. So, and the slope is the single integration. So we're going to take for our, okay, so let's take our first equation is 8x. All right, and if we integrate that, we get 8x squared over 2 plus c1, and that is our slope. Okay, and our deflection is going to be, we're going to integrate that again, and we're going to get 8x cubed over 6 plus c1x plus c2. Everybody agree with that, I hope? Okay, and that is for x is between 0 and 8. Over here we got x is between 8 and 12, and our equation here for m is 192 minus 16x. Cool. So our slope is going to equal integral of that, which is 192x minus 16x squared over 2 plus constant 3. And our deflection is going to equal 192x, so 192x squared over 2 minus 16x cubed over 6 plus c3x plus c4. Let's say the other constant. So far so good? All right. Now we have to find out the constants, and we do that by looking at the boundary conditions. Okay, so our conditions: when x equals 0, y equals 0. Now we're going to call this deflection y, okay? Just for the sake, it makes it easier to graph. Now, why is that a boundary condition? Well, at this end of the beam, when x equals 0, there is 0 deflection. Therefore, there's the condition where x equals 0, y equals 0. Equally, we'll come to the other end. When x equals 12, y also equals 0. And for the other boundary conditions, we have to look at what happens with the beam. We can say that when x equals 8, the deflections are going to equal. Also, when x equals 8, the slopes are going to equal. So let's go when x equals 8, then theta equals theta. The slopes equal the slope. And also when x equals 8, the deflections are going to equal each other. Okay, so those are our conditions. Now we have to go through, and now it's just the awkward maths part, basically, of finding what those constants are. All right, so let's go ahead and do that now. And this is just a little bit of maths. We can do this almost in any order, but I'm going to draw a box around those boundary conditions so we know what they are. Okay, let's do the easy one first. That is this one here. When x equals 0, we'll be using this equation. X equals 0, that goes to 0, that goes to 0, therefore C2 equals 0. C2 equals 0. All right, that was pretty easy. Okay, let's put in x12 into this one. Okay, 192, I'm going to write this equation out a little bit simpler first. 192 over 2 is 96, so y equals 96 x squared minus 16 over 6 is actually 8 over 3 x cubed plus c3x plus c4. All right, and when x equals 12, that's going to all equal 0. So x equals 12 in here, which is 96 times 12 squared minus 8 times 12 cubed over 3 plus 12 times c3 plus c4 equals 0. And what we're trying to do here is get a relationship between c3 and c4, which we'll then use later. This is really solving simultaneous equations. So 96 times 12 squared is 13,824 minus 12 cubed times 8 over 3 is 4,608 plus 12 C3 plus C4 equals 0. Take that away from that and we get 9,216 plus 12 C3 equals plus C4 equals 0. So let's take it over, let's get it in terms of C4. C4 equals 12 C3, negative 12 C3 minus 9216. Okay, we're going to need that soon. So we've used that boundary condition. Now let's have a look at this one. When x equals 8, both of these thetas are the same. So we're going to have to use both these equations. So when x equals 8, that equation is going to equal the same as that equation. So let's put that in. 8 times 8 squared plus c1 equals 192 times 8 minus 16 times 8 squared over 2, sorry, just made that 8, plus C3. Okay, that's going to get us a relationship between C1 and C3. All right, let's go 8 times, ooh, I missed that, 8 is 8 over squared over 2, sorry about that. Okay, so that is 4 times 8 squared. So we've got 4 times 64 is 256 plus C1 equals 192 times 8 minus 8 times 8 squared plus C3 is 1024 plus C3. Okay, let's just put it all in terms of C1. C1 equals 1024 minus 256 is 768 plus C3. All right. And that's that boundary condition. Now let's use the last boundary condition. When x equals 8, those y values are going to equal each other. All right. So 8 over 6 is really 4 over 3. So 4 over 3 times 8 cubed plus C1 times 8 plus C2, which we already know is 0, so we're going to leave that out, equals 192 over 2 is 96 times, sorry about doing it off screen there, 96 times 8 squared minus 16 over 6 times 8 cubed. This is a real pain, isn't it? Plus C3x, which is 8 times C3, plus C4. All right. And what we can actually do is, we've already got an expression of C4 in terms of C3, so we can substitute that in now. And we could also substitute C1. We've got C1 in terms of C3 there as well. So what we'll do is we'll substitute those in there, but let's put some numbers in there first. So we've got 8 cubed, times 4 divided by 3 is 682.7 plus 8 C1 equals 64 times 96 is 6144 minus 8 cubed times 16 divided by 6 is 1365.3 plus 8C3 plus C4. This is page 2. All right, let's go to page 3 and we'll simplify this down further. What we're going to do actually, sorry, at this point we're going to substitute in C3 here. So we've got 682.7 plus 8, instead of C1 we're going to have 768 plus C3 is going to equal, add those two up, the 6144 minus 1365.3 is 4,778.7. That's that, plus 8, and we're going to put C3 in. We're going to keep this, sorry, we're keeping this in terms of C3, so that's fine. C3 plus, and instead of C4, we're going to put in this equation here, which is negative 12 C3 minus 9216. And you can see now that we've got an expression only with C3s in it. So now we're going to work out C3, and then we're going to come back and we'll easily get C1 and C4. So let's work out C3. 682.7 plus 768 times 8, 6144 plus 8 C3 is going to equal 4778.7. Let's do that, 0.7 minus 9216. 9216 is negative 4437.3. There's an 8 C3s there, minus 12 C3s is negative 4 C3s. We'll gather the C3s over one side. So 8 add 4 C3s there, we get 12 C3 is going to equal, and we've got to add those up, take them away from that. So minus 4437 minus 6144 minus 682.7, and that is going to equal gosh, I hope this works out. 11,264. Okay, let's divide it by 12, so we get C3 is going to equal minus 938.7. All right. C3 is minus 938.7. Let's go ahead and find the other C's now. We know that C1 equals 768 plus C3. That's that equation there. So C1 equals 768 minus 938.7. So C1 is minus 170.7. All right. Put a box around that. And now let's go find C4 from this equation over here. C4 equals minus 12 times C3 minus 9216. So that equals minus 12 times negative 938.7 minus 9216. C4 is going to be fantastically big. All right, we've got 938.7 times 12 and 9216. That is 20,480.4 C4. Okay, we have C2, C3, C1, C4. Now, if we plug these into the equations, we'll see if we've got it right. Okay, so let's have a look at our equation. The easiest one to put it into is this equation here for deflection. It's got C3 and C4. So, Y, we'll use 12 for X, and then we should get 0 for all this. 96 times 12 squared minus 8/3 times 12 cubed plus C3x. C3 is negative 938.7 times 12 plus C4. C4, sorry, that's all negative there, which is negative 20,480.4. Let's see if I get this right and I can post this video. All right. 96 times 144, that's that one. 8/3 times 12 to the power of 3, that's that one. Minus 938 times 12, and then 20,480.4. If we add these up, oh, you're kidding me. All right, I'm going to pause this and see what we've done wrong.